Okay, so now we are going to solve the problem. Two sets, two. Okay, so your task is to count the number of ways one number of ways numbers 1 to n can be divided into two sets of equal sums. Okay, so this is the example for n equal to 7. Okay, so let's look at the problem. So we are given some numbers t n, and we have to divide them into equal sets. Okay, so suppose if we take one here, two here, if n is still 3. So this is our only possible option. But if n is still 4, that is we have 1, 2, 3, and 4. So how many ways we can get two set? Either we take 2, 3, 1, 4. This is one possible way. Okay, and this is the only possible way. So I hope you got it. Here in the example, it's given for n equal to 7. So see, you as you can see, there are four possible ways to get 7. To get two equal sum set of equal sum. Okay, so how we will do it? Okay, so let's forget about this problem. Let us first solve a more simpler problem. Suppose we are given some numbers. Okay, we are given some numbers till n, not till n. We are given an array of numbers, and we have to choose. We have to find out if is it possible to get the sum. Let's say a number x. If it's possible to get a number x by selecting some numbers of this array. Okay, so how we will do it? So at each at each I, what we have options. Okay, so now we have reduced up. We will solve first a more simpler question. Given an array, given an array, find out if we can make some x. Okay, so we have to take some subset of numbers, and we have to find out a way that it can make a sum x. So let's start. So suppose we are at the starting point. Okay, now at option at I equal to 0, if we are at starting. Okay, and the initial sum is 0. So I will find out if that's we have at every 1 second. Okay, so we will start. So for at any index I, uh, for any index sum, or if we look from starting. So when I am standing at starting and initially I have sum 0. Okay, so I have to find out if there is any possible way. So what are my choices from 0, 0? Either I can take this one. So if I take this one, then I would check that if it's possible to get my answer, if my next starting index is 1 and if my current sum is 1. Okay, so that is so what I'm checking. I am at index 0 and I want to check if it's possible to make some x or not. Okay, okay, so from here, what are the ways? I can select one in my subset. So if I select one, I would check that if it's possible to make this sum x minus 1, because I already taken one. So now the number I have to make is x minus 1 and starting at index I. Or if I choose to skip this step, then it will be starting from 1 and ending at x. Now again, we would have two choice. I can take either 2x or I can choose to take 2. So now sum would decrease by 2. Similarly, here also I have two steps. Either I can go to 2 by not taking it or by taking it. X minus 1 minus 2 is x minus 3. Okay. So at any point, if I get x equal to 0, that means, so let's write what we have to solve. We have to solve for current index I and thus require sum. Okay. So what would be our base condition? Base condition would be if at any point, let's say sum becomes 0. That is, we have already formed the, then we would return 1. Because yes, whatever formation we have chosen, it was a valid one because we got a required answer. Now, if we move out of bound or if our sum got negative, negative means we already exceeded what we have to make. Okay, so in that case, we would directly return 0 because it's not possible to make it because we have already exhausted our options or our sum became negative. So we already exceeded our answer. So we would return 0. Now, what would be the answer? Answer would be if we answer would be or of two options. If we choose to take this, so if we choose to take this, then the answer would be I plus 1 sum minus array of I, or this is or if I not choose. Okay, so I would simply return that answer. Here I am doing or operation. Or operation means if either by choosing this or if either by not choosing it. By any method, if I can make this sum, then I would return yes, true, or otherwise I will return false. Okay, so this would be our answer for the question. This given an array, find out if we can make some x or not. Okay, so now let's look into our question again. Our question says they are number 1, 2, and okay, and we have to divide them in two equal parts. Okay, two equal sum. Okay, so I if we try to modify it to our previous question, then the array which we were given is 1 to n. Okay, the array which we are given here is 1 to n. Array is 1 to n. Okay, and our target sum is what would be the total? The sum of plus first natural number is n plus 1 by 2. Okay, so this would be the answer of first n natural numbers. Now, if we want to divide the set in two equal parts, so what would be the answer for that? That would be whatever is the total divided by 2. So now our required sum is whatever total of the array divided by 2. So we will find out if it is possible to find the sum of 2 or not. Okay, so required sum is total by 2. So now we converted our original problem into this problem which we have already solved. That is for a given array. We have to check if any sum is possible or not. So we have already converted it to this question. Okay, but the slight modification is here we don't have to just check. Earlier we were just checking if it's possible or not. So it's either 1 or 0. Here we have to tell how many ways are there. Okay, so here we have to tell how many ways are there to do that. As in the question. So how we can modify this? So if you can see, if we just modified instead of or instead of this or, if we modified it with plus, that is addition operation, then I think we got our answer. You got what you guys know what I did? Like earlier, if we got, let's say, if there were, if we take this, then we got 5 ways, that there are 5 possible answers for this. And if we not take this, there are 6 possible answers for this. So what would be the total number of possible answers? That would be 5 plus 6, 11. It's as simple as that. Okay. So what we did, we sing instead of this OR operation, we put a plus operation. So this solved our problem. Okay, so this is it, guys. We have solved the problem. Okay, so what would be our DP? First I, it can go till n, and then require sum. Okay, because we are also considering it, considering that in our state of DP. So sum can go from, sum is n plus 1 by 2 divided by 2. So actually our max sum is n plus 1 by 4. Okay, so it would be n to the power 3. Here n is given as 500. Okay, so it would be around 500 to the power cube. So this is less than 10 to the power 8, nearly not less than, somewhat similar to it. So it will run. Okay, so that was this problem. Okay, let's code. Okay, now for iterative approach, let's directly code that in code base. Okay, okay, so here we will require a mode. What should be the mode? 10 to the power 7. 29 plus 7. Okay, we are given int n. Totally n into n plus 1 by 2. So our required sum would be total divided by 2. Now one more condition. If it's odd, like if the required sum is odd, then we would simply output 0, because there are no possible ways to, we can't divide a odd answer, because what in whatever way we divide our array, it would always be n and n plus 1. So if our total is odd, we can't get the answer. Okay, so that is done. Now we would require a TP. What can be the maximum? Here our maximum can be sum, because we just require, we just have to check if it's possible to make this sum or not. Okay, Now for every I, directly wrote 1 because that way we don't have to check for zero condition and everything. So for this value, what were we looking? So for the current sum, what are the ways we can get it? Okay, so I can either get it if I wish to not take this. Okay, so then the answer would be J only. Okay, if I wish to take it, then the answer would be I minus 1. And if I took it, so whatever the answer to J minus I of I. Okay, you got it. Like whatever, if we are looking for one, so there are two ways to get. So here, what first? Okay, let me define dp of I comma j defines that how many possible ways to get from j is using number till I. Okay, so if we take this I, okay, so whatever number, if we take this I, if we don't take this I, then whatever number, whatever sum, whatever number of ways that was possible to make this sum till I minus 1, that would be our answer. And if we decide to take this sum, then whatever number of sum minus this, and that also is j minus I is greater than 0. Okay, so whatever possible ways which was possible earlier, and now whatever possible ways if we take this. So if the current sum we are looking is 5, so we have to find how many ways we can get 5. So if the current number is 1, we can search for I minus 1 and 4 because we are taking this element. So we will see how earlier how many ways it was possible to make 4. Okay, so I minus 1 and 4. So that's why we subtract it from here. Okay, so we will add both the ways. We will do a modulo, and at last our answer will be dq of m, comma, sum. Okay, so that is our answer. Let us run it. Actually, can- there is a mistake. Oh yes, my mistake. We didn't define our base case. That would be 0, comma 0 is 1. We can get 0 in one way. So why it show 1? Okay, so it's one way possible to get some zero. So now for every what we are between I minus one, j minus I. Okay, so this is correct. And why we are getting one. Okay, guys, wait a second. I will. Okay, guys, I got my mistake. I was just doing a silly mistake. I didn't take the input. So it was showing the answer for n equal to 0 only by default. Okay, so now we have taken the input and it shows 8. The answer should be 4. And why is that? Oh, yes, we have to divide our answer by 2 because it is there are total 8 solutions. That is, this is also possible, this is also possible, this is also possible, this is also possible. So our solution is considering every our code is considering every possibility as one, but they will always be in pairs. So we will just divide our answer by 2. Okay, you can see that 167 would give us our answer. We calculated total number of ways we can get this sum. So we can get this sum in total 8 possible ways. 8 is all are different possible ways, you can see. So what we have to divide. So whenever this is possible, there would be a counter example of for that. So we will divide our answer by 2 and it will give us. Now we can optimize the memory here. You can see we don't require this whole and we just require the previous one. So what we can do, we can just make it on every turn. Okay, now there is one more thing that we have to do it. See, that was I was talking about. Like we have to start from the end. As I told you earlier, the effect will carry forward. Suppose if there were 5 ways where we can get our answer J. Okay, so if we are modifying for current J, then the previous J should already be modified. The previous J should not be modified. But if we are moving forward, our previous answer would be modified. So that will give us some error in our current answer. So that's why if we iterate from backward, as you can see, now this will work. Let us try to submit it. Wrong answer. I think we have done a little bit mistake for some part. Oh, actually, we are moduling, so we can't directly divide by 2. We have to do a modulo 2. Means in modulo, you can't directly divide. So whenever you are doing modulo, you can directly multiply and then modulo, but you can't do division in modulo because this will change the answer. So how would we fix that? Okay, so we would fix that by erasing our answer and division in modulo. What we must do, we must multiply its modulo inverse. So for this, I think you guys should know the concept. So whenever we are dividing in modulo, so what we used to do, we don't directly divide, we multiply the modulo for whatever number. Suppose we have to divide p by q, then what we do in modulo, we multiply p with its modulo inverse of q. So to find the modulo inverse of q, we do q raised to whatever mode we are finding, it is capital M minus 2. Okay, so this modulo M, this would be the answer. So this q is as inverse modulo q. And there are conditions for this, like the M and Q should be prime and co-prime and etc. So this is whole modulo theory. So because of that, we can't simply directly do what we will do. Two and minus two. Okay, or we can say pass two and inverse of two. We will multiply that, and after that we will modulo. Okay, so inverse of a number A will give us. Okay, so I hope you guys know the method for fast division. What I mean by fast division is, sorry, fast. I hope you guys know the method for binomial expansion, like fast binomial expansion. If there is something as 2 to 0 0 0 0 0, then we can't simply iterate through every way. So there is a method for that. If you don't know the method yet, I would suggest you should learn it. So it's like this. It's a whole lecture on its own. So I would suggest that you watch a video of this and later on come to this. So I'm not explaining it here. As you can see, we got accepted. So that was it. So this is fast exponential. expansion. I don't know what the technique is called, but in this you treat the b as in bits. You treat the b in bits. So suppose the b is like in binary, it's something like this. So for one, each time we just multiply, increase the a, and I think you should know this. This is must required. Okay, so see you in the next video. Thank you for watching.